Hello, grade 10s. Today's lesson is on Newton's first law of motion. Newton's first law of motion is quite often called the law of inertia. It basically says that objects want to keep doing what they're doing. If an object's at rest, it's not moving, then it'll stay at rest. If an object's in motion, well, then it's going to stay in motion, doing exactly the same motion it was doing before, the same speed and the same direction. And the only thing that will change that is if we put an unbalanced force on the object. In other words, if we push or pull on the object. When we talk about Newton's laws of motion, we quite often use the words inertia and momentum. Inertia is a property of matter that talks about an object's resistance to change. It wants to keep on doing exactly what it's doing. If it's moving, it wants to keep moving. If it's standing still, it wants to keep standing still. And it doesn't want to change anything about that. The bigger an object is, the more inertia it has. Momentum, however, talks about an object's motion and its resistance to changing how it's moving. So, for example, consider the two trucks in the bottom picture. If they are moving at the same velocity, the yellow truck will have more momentum because it's much bigger. However, if that yellow truck is rolling along very slowly, but the little red car beside it is speeding very fast, it is possible that it could have more momentum. Momentum has two things to consider: the mass, in other words, how big the object is, and the velocity. To calculate momentum, you would multiply mass times velocity. So think about a scenario where you get in the car and you put your cell phone on the dash, and then all of a sudden you press hard on the accelerator and move forward. What you tend to find happen is the cell phone tends to shoot forward onto your lap. Now, why is that? Well, the reality is the cell phone didn't move. The cell phone was standing still on a spot doing its thing, and it wanted to keep standing still on it, the same spot, doing the same thing, but the car moved forward underneath it. The car moved, but the cell phone, because it wasn't attached to the car, tried to stay in the same spot. So it appears as if the cell phone is shot off the dash, when in reality, the dash moved under the phone. You could also think of the reverse being true. Suppose that we are in a car and we're zooming along down the highway, but you're not wearing a seatbelt, and suddenly you slam on the brakes or crash into something. It would feel as if you were thrown forward. You may have noticed this if you were riding on a bus, especially if you were standing up on a city bus and the bus stopped suddenly. You feel like you're being thrown forward. In reality, if the bus was moving forward at 50 kilometers an hour, then you were moving forward at 50 kilometers an hour. When the bus suddenly stopped, you tried to keep moving forward at 50 kilometers an hour. You tried to keep on doing what you were doing. You had inertia. Both of these are examples that describe Newton's first law of motion. Because we can't do this Newton's Law lab in our homes, I'm going to get you to watch a video from the physics classroom that I've included in the description below this video on Newton's first law of motion. And they have several interesting things to read about Newton's first law and some activities that you can try on your own at home. Our next lesson tomorrow will be on Newton's second law of motion.